Okay, let's take a look. So the figure below shows a covered wooden box not drawn to scale. So draw the net of the box and label all the dimensions. So by drawing the net, it's easier for you to see the how many faces there are, and then it's easier for you to find the total surface area of the box. Okay, so in this case, okay, we will draw. So I'm going to draw it here. My drawing sucks lah. So agak lah. So we know that we will have, right? So this is the net, the net. Okay, so this is the net. But again, they want us to put in the dimension. So this is my base, my base. My base here is 5 and 3, 5 and 3. So we know this one is 5 and then this one is 3. Okay, and then when you open up these two faces here, it's these two faces, it's these two faces. So this is 3 and this will be 2. Okay, so over here, this is also 2. Okay, how about the top part? The top part, this one is actually the top of the cuboid, the top. So actually this one now become 3 already, because this is the top, so it's as same as this one. So actually this one, if you want to draw it bigger also can. Okay, let's say I draw it bigger to the same shape as this one. Okay, so this one is the top. Okay, so this is the bottom, this is the top, this is the 2 corner, and then this is the 2 wall. Okay, so you can put in the dimension, no issue. So 2, 2, this side will be 3, this one will be 3. Okay, and this one, of course, this one is also 2, 2, this one will be 5 and 2, and this is 2. Okay, because they asked us to label all the dimensions, so we have to put all the dimensions. Okay, so with this it's easier for you to see how many faces you have. Okay, so draw the net. We are done with the part A. Find the total surface area of the box. So the manual way of doing it is, I missed out 1, 1, 2, 3, 4, 5, 6, 6 faces. What? Will you miss them? No, I never miss out, right? 6 faces, There are 6 faces, The 4 wall and the top and the bottom. Okay, so find the total surface area. So by looking at this, okay, you see here, I have 2 of the 2 times 3, correct? So the total part B, this is part A. So part B, total surface area, we can do it the manual way. So let's do the corner first. So I have 2 times 3 rectangle, so I can say 3 times 2, I have 2 of this face. Okay, plus, let's say the top and the bottom. The top and the bottom is both 5 and 3, 5 times 3. 5 times 3, and again, I have 2 of it. Okay? And lastly, I have the corner. So the corner is 5 times 2, right? Which is this 2, this one. 5 times 2. So I have 2 of the 5 times 2. So total, we have 6 faces. So it will be 2 times 6 plus 2 times 15 plus 2 times 10. Okay, so we have 12 plus 30 plus 20, and that will give us 62. So 62 cm squared. Done. So that's the total surface area. Okay, now next, this one this is one which is a lot of students always don't know how to convert. Okay, convert the answer in B into meter square. Okay, so you need to convert cm square to meter square. So over here, 62 cm square, when we want to convert to meter square, you have to ask yourself, cm, wow, can hit 3.3k already, you're very power. Okay, 62 cm square, okay, cm change to meter, you divide by 100, correct? Because 100 cm is 1 meter. So if you want to change to meter square, you do 2 times. That means I convert to meter, I convert meter square. That means you divide 2 times. Understand? Divide 100 is when you change cm to meter. So when it's cm squared to meter square, you divide by 100, divide by 100 one more time. Okay? So it will be 62 divided by 100, divide by 100, you get 0.0062 meter square. So you can write in this way, but if you already understand how this works, you can actually also write it as 62. Oops. You can also write it as 62 cm squared divided by 100 to the power of 2. So at least you save a little bit pen ink, correct? You will still get the same thing. So likewise, okay, later maybe we'll be converting. If you want to change cm cube to meter cube, then it's cube. So you will divide by 100 to the power of 3. You understand? Okay? So that will be for part C, converting. Now next, they say, okay, now the box, they has to cover it with paint, and it will cost you 0.15 per square centimeter. So look at this one, this is very important. So this is cm squared. So in other words, I already calculate our total surface area. That means we will use this. Okay, just take 62 multiplied by 0.15. So if they say per square meter, then of course you will have to take this value over here. Okay, so in this case for part D, I'll just take 0.15 multiplied by 62 cm squared. Okay, 0.15 multiplied by 62. So we get $9.30. And we're done. Okay, again, this is normal tech stream. So of course, other levels of students also can learn. Okay, so this is the manual way of finding the total surface area. Okay, you can draw out the net so that you can see the face easily. So just now one student is asking whether is it that it is 4 rectangle and 2 square. So it is not necessary. It only happens if this 2 corner is a square, if let's say this is 5 by 2 by 2. If this is 5 by 2 by 2, that means my 2 corner is a square. Then this is 2, 2 ma. Then yes, it is 4 rectangle and 2 square. But for this situation, the 3 dimensions are all different. The length, breadth, and height are all different. That's why all 6 faces are rectangle. Right? Okay? So you see, I see with 3.3K, we cannot hit 5K today. Let's see. Nobody hit 500 combo, huh? Okay? Let's see. Let's take a look at the question number 2. Okay? So over here, a cuboid has a rectangular base measuring 7 cm by 3 cm. Now, they did not give me my height. My height is unknown, question mark. But this time around, they give me my volume. Okay, so how am I going to find the height of the cuboid? So this question is quite applicable for primary school kids also. You all also learn about volume. So you can also apply this. This is a normal tech question. Okay, basic question. So find the height of the cuboid is, I just need to take the volume, which is the 315. Okay, divide by the base area. The base area will be 7 times 3. Okay, this is one way to do it. So I will take 315 divided by 21 and I get 15. So that means my height is 15 cm. Okay, that's one way to do it. Another way of doing it is you can form equation. You can form equation. Hey, who's Jovi? Jovi also know the combo, is it? Can we use Picasso? Form a triangle with the square on the side. No, cannot. You know why? Picasso is first you need a right angle triangle, which although this you can have a right angle triangle. You see, what he meant is like that. But my question is, you doesn't have the slant, you doesn't have the height, you don't even have the angle. So you only have 3 cm. That's why you cannot use Picasso for this situation. Okay, so that's one way of doing it. Another way of doing it is you can form the formula. Length times breadth times height is equals to the volume, correct? So we know volume is equals to length times breadth times height. This is a or. So the shorter way is this one, but you also can do it this way. Volume is equals to length times breadth times height. So fill in the blank. Volume I have it, which is 315. The length I have, which is 7. The breadth I have, which is 3. And the unknown is the h. So this one is 21. So 315 equals to 21h. Then I will say, okay, my h is equals to 315 divided by 21, and I also get 15. So I also can do in this way. Algebraic. If you notice my TikTok, I have been very diligent to do 3 videos for you each day. Okay? And I start to teach on algebraic from very basic, and then I increase the level each day. Okay? Yes, so do follow me. Okay? My first few my first few weeks of videos will definitely be all algebraic. Okay, from the basic I climb all the way up. Okay, so yes, do follow me if you want to improve your algebra, and definitely if you want to improve your math as well. Okay, so this is also one way to do it. Now, they ask to find the total surface area of the cuboid. Right, so cuboid is very straightforward. We have 4 faces. We have 6 faces. Okay, every rectangle has 2 sets. So it will be volume, total surface area. Now part B, part B. The total surface area, we will have 2 faces. So let's say I do by the base first. So it's 2, 7 times 3. Plus 2, 3 times 15. Plus 2, the wall at the side corner, it will be 7 times 15. So make sure you have 6 faces. You have 3 pairs of identical. Agree? 3 sets. 3 sets. And it will be, so 2 times 21 plus 2 times 45 plus 2 times, this too big, 15 times 7, so it's 105. Then you can press the calculator. So 2 bracket 21 plus 90 plus 2105, and that will give us 342. Did I miss out a number? 3 times 15, 45, 3. I think the answer is wrong. 7 times 3 correct. 3 times 15 also correct. 7 times 15 also correct. The whole answer is wrong. Okay, so in the end it is 342 cm squared. Right? Did anyone spot something that I never spot? It's 342, right? But my answer here is wrong. So answer sheet is wrong. So this is 342. Okay? Hi. Okay? Did anyone spot error? I hope I didn't. 3 times 15 is 45. But yeah, correct. Ta-da-da-da-da-da. No objection, right? 342 is correct, right? Shall we move on? Move on. Let's move on. So let's take a look over here. So a gift box is 15 cm long and 10 cm wide, and the depth is 12. Okay, 15 by 10 by 12. Calculate the volume. Easy. So part A, volume is just length times breadth times height, which gives us, okay, thanks Raphael. Okay, so 15 times 10 times 12. Okay, 1800. Okay, and unit cm cube, because this is volume. Next, find the total surface area. Okay, so by now you should know how to find total surface area. Okay, because this is a normal tag, so I'm not using the chim formula to find cuboid volume, total surface area, because I actually wanted to use, usually express students, I will teach them to use the Prism formula, which is the perimeter of base times height plus 2 base area, because that works for all prism, and cuboid it is also a prism. But for now, okay, we shall start it slow, so we shall do the manual way. So when I teach Prism in the 3rd week of the 3rd Wednesday, this is 3rd Wednesday? No, it's the 2nd week. That means next Wednesday when I teach Prism, can you try use that? Yes, I can do that. Let me do the manual method first. Okay, let me do the manual method first. So manual method will be 2, 15 times 10, plus 2, and then I write 10 times 12, plus 2, 15 times 12. So we will have 2 times 150 plus 2 times 120 plus 2 times 15 times 12, 180. And we will have 2150 plus 2120 plus 2180, and that will give us 900. Okay, so this is the manual method. So someone say want me to use the perimeter of base, right? Yes, that one. Okay. So how do we use that? First, that can be used for all prism. So first of all, what is a prism? Okay, I will talk more about prism next lesson, but now just briefly using this as a prism. So prism means you must have a uniform cross-sectional area. Okay, so in this case, a cuboid, you actually have two cross. You actually can have a choice of this shape. Actually, I have a choice of 3 cross-sectional area. I can use this, the one that is shaped as a cross-sectional area, or I can use the rectangle that is facing us, or I can use the base as a cross-sectional area. Okay, cross-sectional area means it's an area that is uniform. Just visualize that this cuboid is a cake. It's right in front of you. Okay, what shape can you cut so that it will be uniform throughout, and that will be called our cross-sectional area. So cross-sectional area and base area is the same thing. But a lot of students always get very confused. It's not base, it must be the one that is facing on the so-called on the ground. But it is not. Okay? It means the base area is supposed to be the cross-sectional area whereby it is uniform throughout. So in this case, I will use this one. I will not use the one because I use this as my cross-sectional area. So the alternative way, I use red color, alternative way, it will be total surface area is equals to perimeter of base multiplied by the height plus 2 base area. So this one, we'll bracket up, this perimeter of base times height actually give us the 4 area of the 4 wall. The 4 wall. So you see, it will be 15 plus 10 plus 15 plus 10. Okay? So it's 15 plus 10 plus 15 plus 10. This is perimeter of the base. I multiply it by the height of the prism, which is 12. And I plus 2 base area, which is 2 times the 15 times 10. Okay? So in this case, we will have 15 plus 10 and times 2, 50. So the base parameter is 50 cm. I multiply by 12 plus 2 of the 150. Okay, so 50 times 12, 600. And we have 300. This is 900 cm square. So this is the same because it's the same shape. Of course, the total surface area must be the same. Okay, so this is using a better way of finding prism. And cuboid is actually a form of prism because it has a uniform cross-sectional area. So this over here, okay, this one will find all the 4 walls. And this 2 base area is the top and the bottom. So if the question says it's an open tank, okay, if the question says it's an open tank, means that it doesn't have a top. then you do not add 2 base area. You only add 1 base area because the top is open. Agree? Okay, so yes, so that will be the more complex formula, but this is a very good formula to apply for prism. For complex prism, whereby you can see that there's many shapes, then this will be a very good way to do it. Okay, let's move on to the next question. Okay. No, I do not agree, Joe. Okay, I do not agree to your statement that EMath is mostly just simple formulas and common sense. No. If you are saying that, does that mean that you do not have to study and we just use common sense and we can get A? I think that's not a very right statement. Okay, so let's go on. Now, volume of a cube is 64 cm cube. Calculate the length of its side. So in this case, this is a cube. Cube means that the 3 sides are the same. Of course, this diagram is not drawn to scale. Okay, so the 3 sides is the same. So that means it's length times length times length. All 3 sides are the same. That's called a cube. So in this case, 64 is the volume. So to find the length, okay, we're going to cube root the 64. Okay, cube root 64. And you will get 4. Okay, so that will be 4 cm, very straightforward. Next, to find the total surface area. For a cube, it's easy. Why? First of all, it's 6 faces, and all the 6 faces are exactly the same. Oh, we hit 5.8K already. Raphael, did you do that? Power. Who contributed to the 5.8K? Okay, so this is for A. Now part B. Okay, part B, to find the total surface area, because this is 6 exactly the same face, 6 square. So the total surface area of a cube very easy. It's 6 multiplied by 1 square face, which is 4 times 4. Okay, one face is 4 times 4, and we have 6 of the exact face. So it's 6 times 16, so we get 96 cm square. So of course for cube, you don't go and use the complex formula. I don't know, I haven't been pressing her. Huh? Not you, then who? Who is the secret student who has been giving me so many likes? Okay? Okay? Maybe it's my moderator. Maybe it's Sam also. I also don't know. Okay? Let's see. Question number 5. Okay, question number 5. So calculator, this one is just press calculator only lah. So cube root 2197 minus 4 square. So of course it's but you'll be surprised, some students don't know how to key calculator. Okay, so cube root, there is one. So this one, everyone knows there's a square root button here. So the one which is the yellow color one is cube root. Okay, so just need to shift cube root, the 3 will come out, and then you just key in 2197. Okay, and press equal, you get 13. So this is 13. And 4 square, okay, 4 square. Please don't scold me for teaching you how to press calculator. You'll be surprised that some students really don't know how to use calculator. Recently, I have a new student who is very, very weak in his mathematics. So weak. He's really very weak. He don't even know how to use the fraction button and changing the decimal and improper fraction button. So I have to teach him from the basic. Yes, he is in Sec 1. So yes, and we are now learning primary school fractions. Oh, then I was telling him that, oh, my primary school worksheets are all inside the museum already, because in the past I teach primary school kids, but I decided now to focus on secondary school kids. So actually I already archived all my primary school worksheet. But I tell him, because of you, I have to dig up all my fraction worksheet, and then we shall start from scratch. Okay, because if I don't teach him the basic, okay, he will be very lost when I teach him the higher level of Sec 1 algebra. He's very lost. So I have to start teaching him the lower one. Yes, that's why my tuition is individualized. Okay, it depends on students. So 4 square, 16, of course. So it's 13 minus 16, so we get negative 3. Okay? Yep, we are halfway through. So now it's more on the using on calculator lah, huh? So let's see, 9 cubed, 9 to the power of 3 minus square root 121. Okay, 718. So part A, 9 cubed minus square root 121 is equals to 718. There is no minus, so I don't have to put any bracket. So you have to be very careful. So B is 4 square. So 4 square plus cube root 343. So 4 square plus cube root 343 will give us 23. Okay? Easy, easy. Okay? This kind of come up with this one. These questions really come out in exam for their papers. I'm not joking. So although it's 1 mark, but when you capture 1 mark is 5 marks. It's also a lot. You'll be surprised that some students take it for granted for this kind of question, and they still get it wrong. You'll be surprised, I can tell you. Sometimes my students, they got it wrong. I just roll my eyes at them. I say I'm speechless. Okay, so now, just now I teach you all how to convert cm square to meter square, remember? And I did hint to you that how am I going to convert cm cube to meter cube. So can someone tell me how am I going to convert 2000 cm cube to meter cube? What should I do? See whether just now anyone learned anything from the very first question when we convert cm square to meter square. So now we need to convert cm cube to meter cube. So what should we do? For Sec 1 exam will come up for this. Sec 1, yes it is. All these papers are from past year paper. Sec 1 normal tech EMath mid-year paper. Okay? All these are from past year paper. Normal tech. Divide by 10 to the power of 6. 100 cube. Yes, you're not wrong. But, ayo, who will remember 10 to the power of 6? Okay, so just now, everyone will always remember 100 cm is equals to 1 meter. Because this one by default, you all must know how to convert. Agree? By default, you must know how to convert, right? So, how I always tell my students to remember is, cm when I change to meter, I divide by 100. Agree? So, if it is square, I simply divide by 100 square. If it's cube, I just divide by 100 to the power of 3. Okay, this is easier to remember. So it means it's divided by 100 to the power of 3. So we will just key calculator 2000 divided by 100 to the power of 3. Because it is cm cube to meter cube. And you will get this. I have to press this side. So it's 0.002 meter cube. And we are done. Okay, so this is how you convert. Next, convert 1250 cm cube to liters. So this, you have to know one thing. Okay, you must know that 1 cm cube is equals to 1 ml. Okay, you must know that 1 cm cube is equals to 1 ml. Don't ask me why. I don't study degree of mathematics, so I don't know how they derive. But 1 cm cube is equals to 1 meter cube. Sorry, 1 ml. So in this case, 1250 cm cube is equals to 1250 ml, and we know that 1000 ml is equals to 1 liter. Why calculator give the answer in SD form? Which one? You mean this one? You mean just now I get the 0? This one? This form? Standard form? You mean why calculator give in standard form? Rafael, do you mean that way? You can shift it lah. this ENG over here, this ENG you can shift it. So this one get bigger and bigger, right? So you key shift, you go the other direction. Got it? Until you see 10 to the power of 0. Because 10 to the power of 0 is 1. Wow, hit 7K already. Can we hit 10K today? Yeah. Okay, so this is also very helpful when you're actually changing the standard form. Okay, so this is also very helpful when you change the standard form. Okay, and so now this one, ml I want to change to liter. I also divide by 1000, correct? So over here we will divide by 1000. So 1250 divided by 1000 liter. So we get 1.25 liters. Okay. And just sidetrack a little bit about standard form. Okay, sidetrack a little bit. Okay, because some students when they do standard form they're very cute they do not know that it's this button here, the times 10 to the power of something. Okay, so they go and like, for example if I 2 times 10 to the power of 5. Okay, so they key in 2 times 10 to the power of 5. Okay, not wrong but okay, see this but you can simply just key 2 times 10 to the power of 5. Let's see how many times, how many buttons I save. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. 6 times I press 6 times I press 6 times, right? 6 times Okay, now I change this one 1, 2, 3. I save half of my steps. Correct now? Okay? So you can always use this So even when you are dealing with in standard form division or multiplication, let's say division, right? You can just 2 times 10 to the power of 6 over, let's say 6.2 times 10 to the power of negative 2. You can just key in this way. Okay, so use this button for standard form. Okay, I just now already demo. From 6 steps, I become 3 steps. Okay, so yeah, not relevant here. Okay, let's move on to question number 9. Wrong page. Wow, 8.5K. Who is the hardworking one? Why I only knew after I graduate from secondary school? Raphael, 你已经 graduate 了咩？你不是还在 secondary school 咩？是我忘记了吗？ I thought you are still in secondary school. Actually, many students don't know that one. I also don't know why. But now you know, Never mind, you can teach your junior. Okay? I'm used to pressing manually. But you got the point. Yes, Crimson. Oh, Raphael already graduated. All along I thought you are still in Sec 2 or Sec 3 then. I'm a teacher, but not in a government school. Yes, of course I teach A-Math. Yes, Crimson, actually, yes, because you see, if let's say the questions, let's say, although during exam, they will only come out maybe 2 questions of standard form. But every steps, we save 3 steps. Few seconds save here and there, actually we can save quite a lot of time to do another question already. Okay, so let's take a look at question number 9. Okay, I teach both E-Math and A-Math, Singapore Math. Yeah. Sec 1 to Sec 5. Both EMath and AMath. Anyway, upcoming September, I have an O Level crash course, AMath O Level crash course. If you're interested, you can register. Go to my link and click the on my bio. How you study math? Frankly speaking, it's already about practicing. After that, you have to learn the concept. Of course, concept is either you have to learn it from school, learn it from outside tutor, okay, or learn it yourself. I don't know how, from textbook example. Okay, and after that, after you understand the concept, you must always practice, because even one topic or one chapter, you can come out a few varieties of question. So you still have to keep practicing to expose yourself to more variety of questions, so that when during the exam, when you see the questions, you will know how to tackle. The more you practice, the more variety you exposed to, then you will be able to tackle more questions, right? Okay, now let's take a look. No, I'm Singapore. 我不是马来西亚人啊。Do I sound like Malaysian? No, I'm a Singaporean. Okay. Oh, who got? Why Ben was muted? Oh my God. Sam. Sam, if you are around, can you later unblock the Ben? I don't think he's meant to. I don't know who is blocking. I don't know whether is it Sam or is it. Okay, Sam, unblock the Ben. I think the Ben is just saying that I'm from Malaysia. I don't think he's meant to disturb lah. Okay, let's continue our last two, question 9 and question 10. Wow, without me knowing, you already hit 10.4k power leh. Sometimes lagging, so pop up two of the same comment. No, they don't block when it is same comment. I think they block when they feel that they are disturbing lah. Ayo, I cannot teach you pharmacology. You too powerful already. I think you also block me. Okay. I think the moderator are not in a good mood. So you all better be careful. Okay, come. The solid below is made up of several 2 cm cubes. Okay, 2 cm cubes. So calculate the volume of the solid. So in this situation, we cannot use how we do our volume of cubes or how we do our volumes of cuboids. Okay, we're going to do one volume, a volume of 1 cube. Okay, volume of 1 cube. So in this case, they tell us that it is a 2 cm cube. That means this is 2 cm, 2 cm, and 2 cm. So you will find volume of 1 cube. So for part A, you will find volume of 1 cube. So it will be 2 times 2 times 2, which will give us 8 cm cube. Okay, and then after that, let's count the number of cubes we have. So of course, what I see is like 1, 2, 3, 4, 5, 6. Many students are only 6 cubes. No, there is hidden this one. You can see that actually you visualize that you remove this. Okay, there are actually 2 levels. So 3 at the top, 3 at the bottom. So actually over here, this side, it has actually 6 cube. 6 cube. Then you plus the in front 3. So total you actually have 9 cubes. 9 cubes. So the volume of the solid, it will be 8 multiplied by 9. Yeah, I write 6. And it will be 72 cm cube. Okay, I'm not so sure you all know. Actually, I'm very bad with 9 timetable. So I always use my finger. So I hope, yeah. I memorize my 1 timetable to 8 timetable. But 9 timetable, I use my hand. Like for example, 9 times 8. 72. Okay, if you notice from my video, when I have to do 9 timetable, my finger will move. Okay, let's do the last, not the last, sorry, part B, the total surface area. Oh, this is tough. Okay, this total surface area will be tough. So in this case, you will have to find one face. So our one face is 2 by 2. Okay, so one face, it will be 2 times 2, which will give us 4 cm squared. So the total surface area for this one is pretty tricky. You will have to count the number of face you see. So you have to visualize that this solid is right in front of you. So how many face do you see? Okay, let's take a look. So let's start with the simple one first. Look at this 3. So I have 3 here. The other side here, when I look over here, it will also have 3. So I already have 6. So let me put down the 6 face first. Now, let's take a look at behind. Let's take a look at behind. Behind. So, just now we have agreed that we see 6, right? 1, 2, 3, 4, 5, 6. So, they are actually behind, you will see 6 faces. Okay? 1, 2, 3, 4, 5, 6. Behind. I'm talking about behind. Back view. Back view. So, I have 6 face behind. Okay? Now, let's take a look at the bottom. Bottom. So, bottom also have 6 cube. So, same thing, you will also have 6 faces. The bottom. Okay, now I already settled the 2 corner, the back view, and the bottom view. So now we left with the front view and the top view. So now let's take a look at the top view. Or rather, let's count. This one very obvious, we can see already. So now I left with 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I have another 12 faces that I need to add. So this will be the total faces that I will see. Okay? And multiply by 4 cm squared. So it will be 18 plus 12. So it will be 30 faces times 4, which will be 120 cm squared. So this is a little bit tough. Why? Because you need to visualize the face. So you need to be very systematic. So you can see what I did was, okay, one corner I visualized. Then I settled all the difficult side first. The 2 corners, then the back view, the bottom view, and then after that I only left with the front and the top. The front and the top view I can just count this way. And then just add them together. Okay, so that's how you find the total surface area of this funny shape. Okay? Okay, now we are going to be at the last question. So of course the difficulty increased a little bit. Okay? Okay. So wow. So hardworking, you all reached 13K already. So for those who are not so sure how to play with the light thing, okay. This is normal tech, Sec 1 normal tech volume total surface area of cubes and cuboids. Okay. You can tap on the screen all the way. Okay. You can do combo light. Okay. And then when you click on the you can see at the top left hand corner. You can see the bar moving. You will see the bar moving. Okay, when you reach the max, of course you can continue to hit combo. But once you release, you can see some flower lah. But I can confirm plus guarantee shop that the flower I cannot see because only you can see. Okay. So I have challenged students and see who can hit 500 combo. For me, I think I hit maximum 400 plus, then my finger numb already, cannot press some more. Okay, let's take a look at question number 10. A water container is made up of 2 cubes. Okay, they are saying this small one is cubes, this bottom one is also cubes. And then of length 5 cm. Okay, this is 5 cm as 15 cm respectively. So water is poured into the container reaching a depth of 5 cm in the big cube. Okay, so they ask, find the total volume of the water container. Okay, this one is this. So you have to read very carefully. Whether is it they want the volume of the water in the container, or is it they want the volume of the container? So they want the volume of the water container. It means that I want the capacity of this container. It means how much water can it hole. So in this case, we will find the volume of the big cube plus the volume of the small cube. Okay, so for part A, the total volume, it will be the big cube, which is 15 to the power of 3, which is 15 times 15 times 15, plus 5 to the power of 3. Okay, so 15 to the power of 3 will give us 3375 plus 125, and that will give us 3500 cm cube. So that is the total volume. Wow, how you key cube inside the phone? So powerful. Okay, so let's take a look at part B. Part B. Okay, find the total surface area of the container that is in contact with the water. In contact with the water. So this one, they are saying that the container in contact with the water. So now let's take a look at the face. Okay, we again analyze slowly. First, okay, in contact with water. So let's analyze. First of all, the easier one is, of course, the water will touch the base, right? Okay, the water will touch the base, and the base is 15 by 15. So one of the face will be 15 times 15. And we have the 4 wall. This face here, this face, and this face, and the behind will actually touch the container. Okay, so we just need to find the 4 faces. So let's analyze. So this face we're talking about over here, it will be 15 by 5. This side also 15 by 5. Agree? This side also 15 by 5. And the behind also 15 by 5. So actually the 4 faces are all 15 by 5. So I just need to do 4 multiplied by 15 by 5. So common mistake is, students say, oh, the top also need to calculate. No, they're asking you container in contact with the water. The water on the top part is not contact to the container. It is touching the air, not the container. So you do not include this top face here. So it is only this. Okay, so 15 times 15 give us 225, and we will have 4 times 15 times 5, which give us 300, and it will give us, oh, the answer is wrong, 225 plus 300, so it's 525. I got miss out anything? Don't have Yes, I'm confirmed plus guarantee chop, I'm correct. Okay, so it is 525 cm squared. Okay, 15 times 15, the bottom touch water, yes, correct. The 4 corners touch the container, correct. The top part doesn't touch. 1, 2, 3, 4, correct. 15 times 5, 15 times 5, 15 times 5, 15, yes, correct. Unless I key correct wrongly, 15 times 5 times 4 plus 15 times 15. Yep, we are correct. Okay, so 525 cm square is the, you don't understand? No, you just visualize this water touching the container. The water that touched in contact with the container. So the bottom, of course the water will touch the base, right? So we have a 15 by 15. So that's one face that's touched the water. Joya, 你在这里呀, Joya. Okay, and then after that we have the 4 faces. Because the water also touched the container. So it is 15 by 5 because the depth of the water is only 5. So it's 15 by 5. So this one is 15 by 5. This is also 15 by 5. This is also 15 by 5. And this is also 15 by 5. So 4 corner of the wall face also touch the container, the water. So that's why we have 15 by 5, 4 of the face. Okay? And these are only the faces that touch the container. The top part here, it doesn't touch the container. It is touching the air. So it is not included. Okay, so we have 15 by 15, which is the base, and then the 4 wall. So add together, it will be 525 cm square. Okay. Okay, so that's all for today's question.